Video, I'll be going through the College Algebra Unit 4 exam on polynomials. The directions for part 1 say simplify each polynomial problem using the indicated operation. Show all work. Answers should be written in descending order. So when we take a look at our first example, we notice first that it is subtraction. So what you should have done first is distributed that negative or -1, and the first polynomial is going to stay the way it is. And when we distribute that negative, it changes all signs in the second polynomial. So now what we need to do is combine like terms. I'm going to start by combining the terms that have the highest exponent, so the exponent of 4. We're going to combine the coefficients. -3 plus -11 is -14, and our n to the fourth stays the same. The next highest exponent is squared. When I combine those terms, I get a +7, and the n squared stays the way it is. Then we have a +8n that can't be combined with anything, and we have a +7 that cannot be combined with anything. So our final answer is this polynomial here for number 1. In number 2, we notice the operation that is really between these two sets of parentheses is multiplication. So because we are multiplying a trinomial times a binomial, when we go to use our box method, I want it to be a 3 by 2 box. So I'm going to write the trinomial across the top and the binomial down the side, and I'm going to carefully multiply to get what's inside each of these boxes. So we're multiplying the coefficients, and we're multiplying the variables. And when we multiply the variables, we have to remember to add the exponents. Be careful here in this last box where I just got the +16. It was a -4 times a -4, so that's why it's a +16. Then we combine any like terms that we see. So I see two terms that have the same exponent. I'll combine those. And I see another set of terms that have the same exponent, so I'll combine those. So in descending order, we're going to start with our highest exponent of cubed. We're going to combine the two terms that have the n squared. That's going to be a +8n squared. We're going to combine the two terms that have the n -32n, and then the +16 cannot be combined with anything. This polynomial is our final answer for number 2. In number 3, we are dividing a trinomial divided by a monomial. So the way that we approach this type of problem is we need to divide each term in the first polynomial by the monomial. So I'm going to be writing this divided by 6m squared y squared underneath each of the 3 terms in our first polynomial. So then let's start by dividing what I just highlighted in blue. 12 divided by 6 is 2. M cubed divided by m squared is m. And then the y squared divided by y squared is a 1, which essentially cancels out. Then we have a +18 divided by a +6. That's a +3. The m squareds divide out to give us 1, which doesn't need to get written. And then the y cubed divided by y squared is y. Finally, we have our +3 divided by +6. That's going to be a +1/2 or +0.5. And our m squareds and y squareds both divide out to give us a 1, which does not need to get written. So this is our answer for number 3. In number 4, the operation that we see is addition. So the way that we approach addition is we jump right into looking for like terms. So I'm going to start with the highest exponent, which is the squared. I'm going to combine those like terms, combine the coefficients, but the variable and its exponent stays the same. Then I see n terms. +8 plus -11 is a -3, and the n stays the way it is. And we have a -4 and a +2, which is a -2. So this polynomial is our answer for number 4. The part 2 directions state that we're supposed to factor each polynomial below completely and show all work. So in number 5, we see the binomial 16x squared minus 25. The first thing we're going to look for is a GCF, which in this case 16 and 25 only share a factor of 1. which doesn't help us in that GCF step. So because this polynomial is 2 terms, I'm going to investigate to see whether it's a DPS. So if I can successfully take the square root of both terms, then this is a DPS. Square root of 16 is 4, square root of x squared is x, and the square root of 25 is 5. So this is a DPS, and it's going to get factored into 2 binomials, 2 sets of parentheses. One will be a plus, one will be a minus, and we're going to put that 4x and 4x, and the 5 and the 5, and this is factored completely. In number 6, we see a 4-term polynomial, and the first thing that comes to mind is that we are likely going to be factoring by grouping. But the first thing we want to look for is a GCF that's common to all 4 coefficients. And if you investigate this, you will find that there is not a GCF for 24, 64, 21, and 56. So we are going to jump into factoring by grouping. When I group the first 2 terms together, 24 and 64 has a GCF of 8. R cubed and R squared has R squared in common. Once I divide out that 8R squared, I'm left with 3R minus 8. Then we have to take a look at our second group. Remember, this sign right here, this negative, is going to get brought down. The GCF for 21 and 56 is 7, so this is really a negative 7 that we're dividing out of both of these terms, and that's going to leave us negative divided by negative is a positive 3, don't forget the R, and then a positive 56 divided by a negative 7 is a minus 8. We want to make sure that the binomial here and the binomial here match up, which they do. So our final answer comes from taking the outside terms, the 8R squared minus 7, and the inside expression, 3R minus 8, and this is going to be our final solution that's factored completely. In number 7, we see a trinomial. The first thing, of course, that we're going to look for is a GCF. The only thing common to 7, 53, and 28 is a 1, which isn't going to help us, and then there are no A's in common to all 4 terms. So the GCF is 1, which does not help us, so what we have to end up doing here is, because the coefficient in front of the A squared is not 1, this is going to be our AC method. So our first step is going to be to multiply A times C. A is 7, C in this case is positive 28. 7 times 28 gives us 196. The second step in our process is to find factors of 196 that add to our B term, which is positive 53. So with a little bit of investigation, we can figure out that the factors that we're looking for are not 1 and 196, not 2 and 98, but 4 and 49. So we're going with 4 and 49. So in our third step, this is where we're going to split the middle term. So I'm going to suggest that we rewrite the original trinomial, and the first term and the last term stay the same, but we're splitting that positive 53A now into a positive 4A and a positive 49A. The way we proceed is factoring by grouping. The GCF in that first group is A, and that leaves us with a 7A plus 4. Remember, that comes from dividing by the GCF. The middle term, which is a plus, comes down, and our second group, 49A plus 28, has a GCF of 7, and when we divide by 7, we're left with 7A plus 4. The two meals here do match up, 7A plus 4, 7A plus 4, so we're on our final step, which is to write our outside terms, A plus 7, and our inside expression, 7A plus 4, and that is our final answer. In number 8, the first thing we want to look for always is a GCF. So 3, 15, and 42 does have a GCF of 3, But also look at the variables. There's an x, x, and x. So there is an x in common. And then if we take a look at our n's, we notice that there's n squared, n, and then no n's, which means there's not an n that's common to all three terms. So we want to go through and divide each term by the GCF. We have to remember to keep that GCF as part of our problem. So the 3x is going to get written out front with what left in parentheses. Well, that's where we want to divide here. 3 divided by 3 is 1, don't have to write it. X divided by x is 1, don't have to write it. All we have there is an n squared. Then we divide negative 15xn divided by 3x. Negative 15 divided by 3 is negative 5. X divided by x is 1, don't have to write it. And we bring down the n. And then finally, we have our negative 42x divided by 3x. That's going to give us negative 14, and the x's divide out to give us a 1, which does not need to get written. From here, we need to investigate what's in these parentheses. This is a trinomial that we have to figure out whether it can be factored or not. So this is where we would be looking for two numbers that multiply to negative 14 that add to negative 5. So when we investigate our factors, it's either going to be 1 and 14, one of those is positive, one of those is negative, or 2 and 7. One of those is positive, one of those is negative. And the factors that we want that add to a positive 5 are 2 and negative 7. So I'm bringing down the 3x GCF, but now this trinomial is getting factored into n and n, positive 2 and negative 7. This is factored completely.